What could a game of pool, a messy car crash, and a magnificent rocket launch possibly have in common? Well, there's a hidden rule, a fundamental law of the universe that connects them all. It governs everything that moves, and trust me, once you see it, you're going to see it everywhere.
So here's our game plan for this explainer. We're going to start with that shared secret, that puzzle. Then we'll build up the concepts we need to understand motion. After that, we'll uncover the one profound rule that governs it all. And finally, we'll use that rule to connect the dots and make sense of everything from collisions to rockets.
All right, let's dive right in. We're starting with a question that seems pretty simple on the surface, but the answer, well, it goes surprisingly deep. Yeah, think about it. A game of pure skill, an unfortunate, chaotic accident, and a triumph of human engineering. You'd think they're from completely different worlds, right? Wrong. They are all, and I mean all, playing by the exact same physical rulebook. So what is it? What's the secret they all share?
To crack this case, we need our first big clue. We need a way to actually quantify, to measure motion. And lucky for us, physicists have the perfect tool for the job. It's a concept called momentum.
You know, the original Italian term was quantita de moto, which is just fantastic. It literally means quantity of motion. But I think there's an even better, more intuitive way to think about it. Unstoppability. It's that simple. The more momentum an object has, the more unstoppability it's got.
So how do we figure out this unstoppability? Well, it's not just about how fast something's going. That's only half the story. It's actually a combination of two key things. An object's mass, how heavy it is, and its velocity, which is really just its speed in a specific direction. You absolutely need both.
And this is where things get really interesting. Let me ask you this. Which is harder to stop? A huge, massive truck just slowly rolling down the street, or a tiny little bullet zipping through the air? The answer might surprise you. They could have the exact same momentum. One has enormous mass but very little speed, while the other has almost no mass but an incredible, off-the-charts velocity. Okay, so objects have momentum. Got it. But things speed up and slow down all the time, right? So how do you change an object's momentum? How do you get something moving in the first place, or bring it to a stop? That brings us to the next piece of the puzzle.
The answer is a concept called impulse. And no, it's not just a simple push or a pull. The secret ingredient here is time. See, an impulse is a force that's applied over a certain duration of time, and that's the crucial part. The harder you push, and the longer you push for, the greater the impulse you deliver.
This all links together perfectly, kind of like dominoes falling. First, you apply a force to an object. Second, that force acts over some amount of time, which creates an impulse. And third, that impulse directly and predictably causes a change in the object's momentum. That's it. That is the fundamental recipe for making anything speed up, slow down, or change direction. All right, we've got our key players on the board: momentum and impulse, the thing that changes it. Now, let's bring them together for the big reveal. This is the rule that ties everything together. Seriously, this is the aha moment.
This is the law of conservation of momentum. And it is so beautifully simple. All it says is this: you can't create momentum out of thin air, and you can't destroy it. You can only move it around, transfer it from one thing to another. The total amount of unstoppability in any interaction always stays the same. Just look at this. It's the golden rule visualized. Imagine those billiard balls again. If you add up all their momentum right before they collide, and the total is, say, 100 units, guess what the total is right after they bounce off each other? It's still 100. The momentum isn't lost, it's just been perfectly redistributed between the balls. It's the universe's ultimate fair trade. Now, there is one little piece of fine print here. This perfect conservation happens in what scientists call a closed system. All that means is an interaction where there are no sneaky outside forces, like friction from the ground or air resistance, messing with the final count. For things that happen super fast like a collision or out in the vacuum of space, this law is basically ironclad.
Okay, it is payoff time. We've got our universal law, our master key, so let's go back and finally unlock that puzzle we started with.
Let's start with collisions. They come in two main flavors. First, you have elastic collisions. Think of those billiard balls again. The cue ball smacks into another one, perfectly transfers all its momentum, and stops dead in its tracks.
Then you have inelastic collisions. Now think about that car crash, where the two cars crumple and get tangled up. The total momentum they both had before the impact is now just shared by their new, combined, mangled mass. So whether they bounce apart or stick together, the total momentum is always conserved.
And what's amazing is how powerful this law is. It doesn't matter if it's a perfect, head-on crash or just a glancing blow off to the side. Yeah, the math gets a little trickier when you're dealing with angles, but the core principle, it never ever changes. The total momentum before is always equal to the total momentum after, period. And the rocket? Oh, the rocket is maybe the most elegant example of this entire principle. Imagine it, just floating in the vacuum of space. Its momentum is zero. To get moving, it blasts super hot gas out of its engine. That gas has mass and it's moving with incredible velocity, so it has momentum pointing downwards. Now, because the universe demands that the books stay balanced, the rocket must gain an equal and opposite amount of momentum, pushing it upwards. It's not pushing off of anything. It literally moves by throwing momentum away.
And there it is. That's the shared secret. The puzzle is solved. The pool break, the car crash, and the rocket launch, they're all just different scenes from the same cosmic play, all following the exact same script, the conservation and transfer of momentum.
So, if you take just one thing away from this, let it be this. Momentum is the universe's currency of motion. It's the quantity that gets exchanged in every single interaction, and the universe is an incredibly strict accountant. The books must always balance, from the smallest particle to the biggest star.
Which leaves us with one final, kind of mind-bending thought. If the total amount of momentum in our entire universe is a fixed number, if it can't be created or destroyed, what does that imply about the very beginning, about the moment of the Big Bang itself? I'll leave you to chew on that one. Thanks for joining me.